All right, before we get into our lesson, I want you to take a look at these four coordinates and classify this quadrilateral as closely and precisely as possible. Notice that we have variables in this one, which we haven't before. Given that, still look at what you've been given and decide what shape this might be. So let's look to see what we know. We know at point A is going to be 3 units to the left and 3 units up, and that's 3A. Now, with any variable, you can always plug in a number for it, and that will allow you to kind of get a better idea of what it looks like. So the easiest one to plug in would be a 1, because 1 doesn't change the number. So that means we'd go 3 units to the left and 3 units up. And then, so if we kind of graph this, our point here would be 3 units to the left and 3 units up. And our point B, this would be point A. Point B would be 3 units to the right and 3 units up, which would be point B. C would be 3 to the right and 3 down. And D would be 3 units to the left and 3 units down. So if you notice here, the distance here has a total distance from, if you're 3 units to the left, we say that's a distance of 3A. This one's 3A, right? So we have a total distance of 6A. So the distance from A to B is 6A. Now from B to C, we are the same thing. 3 units up and 3 units down. So that's to give us a total of 6A units. Now, even though we have negatives and positives, remember we're talking about distance is always positive, so the distance of this would be 6A. So same thing here. We look at this distance here, we have a distance of 6A. 3 units to the left, 3 units to the right, total of 6 units. And then we have this one here, we have 3 units up, 3 units down, total of 6 units. And so since they all have an A, we say that's 6A. So this object would be a square. And it's a square. And then you could also look at this because the way it's graphed, our slopes are going to be the same for AB and DC. They're both 0, and BC and AD have undefined slope, which means that indicates a vertical line. So these would be a square. So let's look into our lesson now, applying coordinate geometry. So what we're going to do is we're going to name coordinates as special figures by using their properties and not necessarily getting hung up on the letters that we're using. So our central understanding today is you can use variables to name the coordinates of a figure. This allows you to show that the relationships are true for any general case. So let's take a look at our first case. In chapter 5, we learned about the segments joining the midpoints of two sides of a triangle. Here are 3 possible ways to place a triangle in its midsegment. You have figure 1 where the triangle is placed in the first quadrant. Figure 2 is also in the first quadrant, but the bottom side of the triangle, the base of the triangle, is on the x-axis. And in figure 3, it's on the x-axis, but it's also split between the y-axis. So let's look to see kind of how our points would be found and how each one of them differs. So if we're going to find the midpoint, let's locate the points of M and N for each one of these. So for the first one, we're going to start with M. Now, the midpoint formula, remember, is you're going to add your x's and divide by 2 and add your y's and divide by 2. So we're going to take our x's here, a plus c over 2, and then we'll have b plus d over 2. Now, we can't simplify anything here, so this becomes our coordinate for M, which is a plus c divided by 2 and b plus d divided by 2. Now let's look at N. So N is we're going to add the 2, and it doesn't matter because adding what order we add these in. So we're going to have c plus e over 2, and then we're going to have d plus b over 2. So this gives us our coordinates for M and N. So let's do the same thing over here in figure 2 and kind of see how it compared the two different coordinates. Now notice this one has been placed on the x-axis, so we now have zeros because this one's starting at the origin for point P, and R is on the x-axis, so its y-coordinate would be 0. So let's look at m for this one. M, we're going to get a plus 0 divided by 2, and then we're going to get b plus 0 divided by 2. So a plus 0 is going to be a over 2, and b plus 0 is just b divided by 2, so it's b over 2. So this one here, notice it's a little bit cleaner. We have a divided by 2 and b divided by 2 for our coordinate of m. Let's do the same thing for n. This will be a plus c over 2. This will be b plus 0 over 2. So this leaves us with, can't simplify a plus c, can't add those together. But we can simplify here, get b over 2. So notice that don't have quite as many variables as we had before in this one. So let's move this over here so we have a little bit more room. And now let's look at our last one. Now our figure's been split. So we have a few more zeros in our points, in our coordinates. So let's look at m now. So m is going to be over here with a negative 2, a plus 0 over 2. And then our y-coordinates would be 2b plus 0 over 2. Now, in this one here, we add these up, we get a negative 2a over 2, and we get a 2b over 2. Notice that both of these coordinates here, the three coordinates, they have a 2 in both of these, and these just have a coefficient of 1. The reason why they chose that is because it allows the 2 to simplify, and that leaves us with a negative a and a positive b. So much cleaner for our coordinate of m. And we'll see the same thing for n. So as we do these points here, we got 0 plus 2c over 2, and we have 2b plus 0 over 2. Once again, 2c over 2, 2b over 2, the 2's will cancel, and we're going to be left with c and b. So in each of these cases, we were able to find the midpoint. And get a much easier, cleaner looking coordinate. So let's take a look at our first example. Naming coordinates. So what are the coordinates of the vertices of each figure? So let's take a look here. For A, they give us that SQRE is a square where SQ is equal to 2A. The axis bisect each side, which means cut in half. So the full length from here to here is 2A. Now if it's a square, that means the length from here to here is also 2A, 2A, and 2A. So that means if it bisects it, that means the distance from the y-axis to Q would be a length of A. And the distance from here would be A, from y-axis to S. So from the y-axis to R, it would be the length of A. From the y-axis to E would be the length of A. And right here, from the x-axis to Q, it would be A. So we're cutting each of these in half. And from the x-axis to R would be A. From the x-axis to E would be A as well. And from x-axis to S, it would also be A. So those are the distances we have. So what they want us to do is to find the coordinates. So they want to know what is the coordinate of S, Q, R, and E. So if we start at the origin, we're going to walk over here to S. We're going to walk A units to the left. And since we're going to the left, that's considered a negative. So we have negative A. And then we're going to go A units up, which would be a positive A, to get to coordinate S. So let's look at Q. We'd go A units to the right, starting at the origin. and we go A units up. So those are both positive. For R, we're going to go A units to the right, and then we're going to go A units down, which anytime you go down is considered to be a negative. And let's look at E, the final one. We're going to go start at the origin. We're going to go left A units, and then we're going to go down A units, which puts us at a negative A, negative A. So the coordinates for the vertices here for S, R, Q, R, E are going to be negative AA, AA, A negative A, and negative A, negative A. So I want you to try part B. So pause your video and come back when you're done. So let's look what you got. So if TI is 2A, and the y-axis is a median. Median means it's going to go from the vertex to the midpoint opposite side, which means that this segment will be the same as this segment. So let's look here and see what our distances would be. So if this is 2A and it cuts in half, that means this is a distance of A, this is a distance of A. Now for this distance right here, for point R, you can come up with any coordinate you want to choose, any letter. So we can say that this has a distance of, since it's the next letter in the alphabet, we'll call it B. This has a distance of B. So let's name all three of these vertices. We'll have T, we'll have R, and then we'll finish with I. So T is going to be 3 units to the left, or A units to the left, which means we're going negative A. And we're going to go on the x-axis, which means that should have a coordinate of 0. For R, we're going to go left to right 0 since it's on the y-axis. And we're going to go up B units. Now we chose B. You could choose any letter you wanted. I just went with the next letter in the alphabet. And then we have I. I is going to be A units to the right. And we're going to have on the x-axis, so it's going to be 0. So let's move to the next two, C and D. Try these and come back and check your answer when you're done.